Hey, what's up everybody? In this video I'll be going over the 4040 XE by FoxAlien. I'm no pro. I do have a lot of experience with machining, so I wanted to make this video because I know as a beginner it's difficult sometimes, it's frustrating, can't figure something out. So open this video, I can help you guys out. We'll go through a lot of the basics, the programs I use, different things, and so let's get started.
Hi guys, in this section of the video I will be talking about the programs I use to run the 4040 XE. I know this is kind of a popular program. I know a lot of other people use it. I like it a lot. It's called Fusion 360. It's by Autodesk. You can buy it. Also show you guys a way to get it for free. It's kind of an all-in-one program. CAD, CAM, everything you need basically to do anything on the 4040. I've used Mastercam before. I've had experience with it. I've also had experience with AutoCAD, which is also by Autodesk, and it's a very expensive program. It's a very elite program, and Fusion 360 is a lot like AutoCAD because it's made by the same company. You can get a free trial, or you can get what I use and you can do the Fusion 360 for personal and hobby use. So you can get it. That's what I have, and it works fantastic on the 4040. I like it a lot. So if you guys want to, go to Autodesk and download this right here, and you'll be set. We'll get right into it. So here's the blank sheet for Autodesk Fusion 360. So this is how whenever you open it up, this is the start out screen. So this is what I use to design basically about anything I'm making, and then I convert it, manufacture the G code and everything. Well, I manufacture an NC file and puts the G code into the candle program, and then it goes straight into the machine. So I run everything off my laptop. So what I normally do, I'll start out over here. I'll start out in a top view, and then I'll go over here and I'll create my sketch. And so whenever you hit create sketch, you have to point out which plane you're going to be in. So I use this top plane, and then you're right into your sketch palette. So you can do just about anything in the sketch palette. We'll just start out with we'll go. So in the document settings, you can use the units. There's all sorts of units. You can do all of these. A lot of times I do millimeters and inches. We'll set inches as our standard for now. So we can create a rectangle here. So I'll start out here in the main axis, and then we'll just make a 2 by 4.5, I guess. Okay, so now we have a rectangle, and so what we want to do, we want to make this into a shape, right? So we'll go over here to the solid, and we'll extrude this shape. So basically what that does, it stretches it out and makes it a actual object. So say let's go 3/4 of an inch, so we'll go 0.75 and then hit enter, and then we now should have a fully rectangle cube. So we'll go back here to the top. So now we can let's say we wanted to drill a couple holes in this block. So we'll create another sketch. We can click on the top plane. And so now we are sketching on the top surface of this object. So we can take a circle, put it at whatever point we want to, and say let's go here. Then we can go with a 1/2 inch hole. So now we have just a flat 1/2 inch circle. So there's no hole, there's just a circle right now. So we'll escape there, and then we'll go back to our top. So to make a hole, go back over here to solid, and then we hit the hole function. So now that we have the hole function selected, we can go over here and select our holes. So we'll click on that one. And there's all sorts of different types of drill points and everything. So we'll go with just a normal hole, and then we'll go, instead of a rounded, we'll go with a flat bottom hole. So let's say we want to go all the way through the material, so we'll do the same depth as our material, and then we'll have to make sure our hole is a 1/2 inch, just like the circle we drew, and then just hit OK, and then there's your hole completely through the object. Okay, so now if we want to go, say we didn't want to have a hole all the way through, say we would rather just have partial hole, we can make another one here. And then once again we do the same thing, and this time let's only go 1/4 inch in. We got all of our settings the same, so we hit OK. Now we only have a partial hole. So many different ways to do many different things on here. That's what I do for a lot of my game boards and things that I make. Do shallow depth holes and things. In sketching, you can also do text. So if you like to engrave stuff, if you want to cut a big old rectangle out or shapes or whatever you want, So if we wanted to engrave text, we can just make a text box here. So then we can just put whatever in here. And then there's tons of fonts. So I do know there is ways to insert your own fonts. You can download fonts off the internet and stuff and put them into the program as well. There's different types of fonts. There's certain fonts for different things, but we'll just go with the normal font for now. You can create the height, you can bold it, you can do about anything with it. So say we want to engrave. I guess we can go straight into manufacturing. So whenever you have everything you want to manufacture all drawn up and everything, you go over here to, after you get your design finished, you go over here to manufacture. And manufacture, you also have different units and things, different ways to cut. Most of the stuff that I do 2D cutting and stuff. They also have 3D surfaces with lots of contours and things. Holes can be drilled using these drilling functions. Got smart hole recognition, different things like that. For cutting and stuff, a lot of times I use like a 2D pocket, slotting, tracing. For text, I do engraving. So say we want to engrave, and we want to engrave just the letters. We go over here to our tool, and how I set up my tools, I create my own tools. So for a 30-degree V-bit, like the one that comes with the 300-watt spindle and stuff, they don't really have a exact tool preset in here for it. So what I do, I use a chamfer mill. So I set it up as a chamfer mill. So this is what the stock chamfer mill looks like. So we'll edit the settings and stuff to make it look like our 30-degree V-bit. So we'll go over here, we'll put one flute in. Material doesn't matter a whole lot. I just do tie coated. The one with the machine is a 3mm in diameter. Shaft diameter is the same. Tip diameter I put 0.01 in. Overall length, I can't quite remember, but I believe it was around 30mm. Length below shoulder, we'll go 15. Shoulder length 15. Flute length I believe was 6mm, and of course our angle is 30 degrees for the V-bit. So now you have your actual 30-degree V-bit, and this is what the program thinks it looks like, and it's plenty close enough to what the actual bit is. So our cutting data, if you want the program to already know exactly what this tool can handle, you come over here and input the cutting data. For acrylic, I used 10,000 RPMs on the 300-watt spindle. I did a cutting rate of 1,000. My ramp feed rate, I slow it down to 300. My plunge, I do 300 as well. Obviously there's no coolant, so we'll come down here and disable that. And that's about it on the 30-degree V-bit. So we'll go over here and we'll hit accept. And then here's our new tool. So we'll select that one. And then we'll come over here and you'll see the program already knows everything that this tool can handle. So it's already got the spindle speed, feed rates, and everything already preset over here. So we go over here to geometry. We want to select our contours. So we select the lettering. So now it's got an outline of what's going to be engraved. Clearance, that's a little bit of a tricky one for me. Depends on how high you want to, how deep you want to engrave your stuff. I have to play with that one a little bit, but you can see the different heights, the clearance heights, the retracting height, and all that. That's one that you kind of got to adjust what you're engraving and all that. And then it's good having multiple depths and stuff. Depending on what you're engraving and things like that. Sometimes it's good to do multiple depths so you're not taking too much. But as far as engraving goes, most of the time you can get away with one depth a lot of times. So we'll have it set up, and then you can go over here and hit simulate, and then you can watch it engrave the entire thing. And that's about all there is to it as far as engraving goes. And you can kind of see a little bit of the 3D contour there. You can kind of see, get a little depth perception there. As far as drilling holes, let me center this. So we'll go back over here to our holes. Oops. So one good thing about this program, they have a hole recognition function, so you can automatically recognize the holes, or you can go in here and select them manually. For the hole drilling, you can set up your own bit or whatever. I normally do mine with a flat end mill, well, depending on what you're trying to accomplish with it. My flat end mill on my DeWalt spindle, it's a 1/4 inch diameter shaft, and it's a 2-flute bit. It's a carbide. Diameter's 1/4 inch and whatnot. I actually have this. Let's cancel this real quick. Let's go back over here. Let's set these units to inches instead. So we'll go back here. Let's recreate our tool here. I use the flat end mill. So mine have 2 flutes, carbide. I didn't even realize there was a. So mine's 1/4 inch, 0.25. Shaft diameter 0.25. My overall length's 3 inches. I'm not sure what my length below the shoulder is. Let's just put 1.5. And then we'll just put 1. shoulder length. And we'll put 0.75 for the fruit length. So there you have it. There's the flat end mill, 1/4 inch, 2 flute. I know a lot of the ones that come with the 300 watt spindle, they're much smaller. I use the DeWalt router that I got for an upgrade for the machine, so it uses 1/4 inch diameter bits and things. Cutting date on that, on the 300 watt spindle I use 10,000 RPMs. My cutting feed rate is usually 1,000 millimeters a minute, and then my ramp feed rate, I do 300 on it, and the plunge feed rate I do 300 on it as well. So we got 10,000, so we go 1,000 here. We got 300, 300. And then of course there's no coolant on it as well. And so there's your flat end mill if you're, say we're drilling this 1/2 inch hole. So we select that. And then, so we're disabled, and then once again, spindle speed, plunge rates, and all that are already preset. You can do multiple heights. You can do several different cut types. You can bore, thread, you can have a tap drill, all sorts of. A lot of times I do a boring type drilling, so where it spins around and around and slowly goes downwards in a spiral. Okay, so for the drilling part, I'll get the milling part figured out. So we'll go over here. So we got our 2 hole faces selected. We have our tool. Our spindle speed's already preset through the tool. Plunge rate, ramp feed rate, everything's already preset. We'll go over here, clearance and everything's all set. So we're going to go with bore milling. Our diameter is going to be the same as our hole. So we're going to have 2 1/2 inch holes. And we should be good to go. So here it is in simulation. So we'll go up here to simulate. Double check our work. We'll hit the play button. And by the end of this, we should have 2 nice 1/2 inch holes that have been bored out through the bottom. And there we have it. 2. So now you can see the tool path for each one. As you can see, they go round and round all the way down to reach the bottom. So as you can tell, we only put this one 1/4 inch in, and then we went all the way through on this one. There we have it. Through this program, there's many different things to do other than just this. This is just a couple simple things that I typically do on a lot of projects. I drill lots of holes, I do a lot of engraving. Hope this helps you guys kind of get started. I know just even little bits of information can help. Now that we have our two manufacturing processes set up, we'll go over here and we'll create an NC file to send over to our machine, to send over to Candle, and our processor can generate the G-code and put it into the machine. So we'll right click on setup 1 here, so that includes everything that we just did, the engraving, the drilling the holes, and it'll also do all this in order. So if you got, for example, if you have something with writing on it and then you also have to cut it out, a lot of times it's better to have your writing first and then cut it out, so you're not running into problems. There's also ways to set up tabs and all sorts of different things. So there's many different ways to do it, but that's one example that you might run into a problem where if you cut it out first, your part might move before you get it engraved or whatever. So we'll right click on the setup, we'll create our NC program, and so we'll just name it block 1. And then you want to put it wherever you're wanting to take it, your output. So I put mine in this FoxAlien folder here. You want to make sure it's an NC extension. Units you want in millimeters. Everything else should already be set up. Make sure this is set to GRBL, and then should be good to go other than that. And then we'll go over here, we'll hit post. So the NC code was successful. That brings up the Visual Studio. So now here's all of our lines of G-code. And on this particular program, we have 743 lines of G-code. So there's lots and lots of G-code. It goes into even just something as simple as just this block with some lettering and stuff on it. Okay, in this section of the video, we're going to go over a few key things to make your machine run right before you start. Whenever you first get this thing out of the box, you want to go through every single bolt on this whole thing, every single thing, so that they're all tight, nothing comes out, you don't have to worry about anything. Also, another important thing to check on is your stop switches. Make sure that these bars right here aren't bent, so that whenever they come up to their point, they'll stop the machine in its place. I know, like on mine, I have the DeWalt router, so these bolts here, I have a little bit of Loctite on each of those to help keep the shaking out and to help those not back out. I just use a medium strength Loctite. I know a few things that happens quite often is like mine, whenever I first got it, the emergency stop was pressed down. So for firing up your machine, make sure that is released and pulled up. Also, I see this all the time. There is a switch over here on the side of the control box, and so if you're like me, I run it on my laptop. So make sure this is switched over to computer mode instead of controller mode. And when that is, this touchscreen right here on the front of the control box should be off, and then you won't have a bunch of problems. I know whenever I first had it, I forgot to do that, and I had a lot of issues with my parts skipping around and the tool paths weren't cutting right. And then also another thing to make sure on these belt tensioning deals and stuff, make sure all of these set screws are tight and then your belts are tensioned right. That's very important for your machine to run smoothly without skipping around and jotting around like it shouldn't. And make sure all your wires are connected correctly and all that, and you should be good to go. Okay, we are gonna open up Candle now. So we'll go to our FoxAlien folder. I'm on Windows. Go over here to the software, Candle, and here's our application. The first time opening, you'll have to extract all the files. And here's mine opened up. So to connect this to the machine, you want to plug in your USB and then make sure your controller box is switched to computer mode, and the switch is located on the left side of the controller box. And then we want to turn on our machine, and then we'll go up here to settings, and then you're going to find your COM port. On mine is COM 7. I use Surface Pro 6. Sometimes you might have to unplug your USB and plug it back in. And then now that it's saying it's ready and connected to my machine, since the alarm's popped up. So to reset the alarm, we want to hit reset and unlock, and then now it is in the idle state. So now we want to insert our NC file, so we'll go over here and we'll hit open. We'll find which NC file we want to go with, and then this is just one I created for a project I did. And so here's my part. I created Joker game boards. I even have it where it's got tabs, to where when I cut it out, it leaves tabs behind, holds the part in there, and then should be good to go. So to use your Z probe, you want to line up your X and Y first, and then you'll come over here and then you'll zero your X and Y, and then you want to hook up your Z probe, and then you use this. And your Z probe is 15 millimeters thick. Here's your Z probe. So it's already set to 15. So, and it's in millimeters. So whenever you use that, it automatically knows that your block on your Z probe is 15 millimeters thick. So when you use that, it'll automatically put you precisely where you need to be.
Or you can use the old-fashioned way and put a piece of paper in between, and then you jog your Z-axis down until you have that piece of paper just snug in between your cutter and your part. That's also another way to do it, if you'd rather do that instead of hooking your Z-probe up. And then once we get it all lined up and correct, we zero it in, and then we go down here and we hit send and let it rip. And then if you want to pause in the middle, if there's something you need to pause for, you just hit the pause button. If you need to abort the whole process, just hit abort. And if something goes wrong, remember you always have your emergency stop to hit on the top of your control box, and that'll stop the machine in its tracks. And then also, when you use that and you release it, it's also going to set that alarm off. So you release the emergency stop button by twisting it and pulling it up, and then so you just come back in here, you hit reset and unlock, and you're back in your idle state, ready to go again. Alright guys, I want to show you something that's really cool with Candle. Not a whole lot of people will probably know about this. Sometimes on your machine your spill board is a little off. So what a lot of people do, they create a file and they cut their entire spill board down so that when they set a part on there and cut, their cuts turn out nice and flat and straight like they're supposed to be. But I'll show you guys a way that you don't have to do that. And Candle has a really cool thing, and it's called a Heightmap. So basically what it does, it reads all of the curves in your spill board, and you don't have to sit there and cut your spill board apart, because doing that will also mess with putting like say a bigger part in there that uses the entire spill board. Well, your machine can't cut the whole spill board, so essentially if you cut only the half and you put a bigger part in there, well, it's going to be off anyway. But with the Heightmap, you don't have to worry about that. So what you want to do, you want to go over here to your settings. Okay, you want to scroll down to panels, and then you want to click this Heightmap. So then you get this tab over here, and then you can use a Heightmap, which this will be unclicked when you first do it. So see, now it's just nice and flat. But if your spill board's got a curve in it, or maybe say like mine's higher on one end than it is the other, so I can make a slant on the Heightmap to make up for that slant on my spill board. So I just kind of did a test here. You can see mine. I just put like it's got a big dip in the middle of the spill board, but I made this one really obvious so you guys could see it easier and know what I'm talking about. You can see the difference there. So what you want to do, you want to do this here, and then you can set as many of these probes as you want. If you already have like a part here, it also has this auto function to where it automatically tells you what the perimeter is all the way around it. And then you can create your grid here, and so we'll just put a bunch of random numbers in here so you guys can see what I'm talking about. Let's say I got a dip here in the middle. Go 8 like that. So if you look, then it comes down here. It has that nice curve to it, so it makes up for that in your spill board. And you can set as many of these as you want if your spill board's all messed up or whatever. But so that comes in really handy for making more accurate cuts without having to resurface your entire spill board and getting to cut a bunch of stuff like that. So then whenever you use that, then you just go over here and use the Heightmap on whatever part you got, and you can also save it and use it for a later time also, so you don't have to come back in here and do this every time. You can just open the file up and open it and use it. You're good to go. Alright guys, I think that does it for this video. I hope I help you guys out. If you would, leave a like, comment, subscribe to the channel, maybe even convince FoxAlien to send me a couple keychains, and I'd like to hear your feedback. Tell me what you think, if there's any more videos you'd like me to make, but until then, we'll see you guys next time.